Welcome to Sensible Cyber's creating a 2-node Hyper-V cluster with StarWind Native SAN for Hyper-V. In this episode, we're going to discuss some of the benefits and features of using StarWind Native SAN software for Hyper-V for high availability and failover clustering as opposed to a traditional SAN appliance. First, we're going to take a look at a traditional clustered network environment. In a traditional clustered network environment, you have 2 nodes or host servers that are interconnected through 3 separate network interface cards. Your first network interface card is your public access or your public interface. This is so that the virtual machines that are running within the cluster itself are still accessible by objects that are outside of that cluster environment. Your second network interface card is your heartbeat connection, and this is achieved through a crossover cable connection between the 2 nodes. And your final network connection is your iSCSI network. Now this is where the host systems actually access the storage that is held within your storage area network appliance. Now this is going to be a very expensive system. On the low end, your SAN appliances run about $3,000. But it's critical because it does increase performance because there are a lot of features within a SAN appliance that you can achieve that you cannot achieve with traditional internal storage. Unfortunately, in this scenario here, the SAN appliance actually serves as a single point of failure. So we don't have the true high availability that we're looking for, in addition to the increased cost of actually purchasing, configuring, and installing a SAN appliance. Now it is possible that you can have multiple SAN appliances and that you use a feature that is known as shadow voluming or disk mirroring between the 2 SAN appliances. And in that case, then your LUNs or your data stores would be presented to each one of the nodes independently, and those nodes would actually be mirrored between each other. And that would give you the high availability that you would want so that if one SAN appliance goes down, you're still able to access your virtual machines or your applications that are virtualized within your cluster. But that comes at a much bigger price point than a single SAN by itself. And you could be looking at $10,000, $20,000, $30,000 even for a very simple basic implementation. Now before we get started in the actual installation and configuration of the native SAN software and deploying the clustered services, we need to take a look at what hardware architecture we're going to need to have in place in order to achieve our end results, which is a true high availability environment at a very low price point. So the first thing we need to have is that we need to have 2 servers with identical hardware architecture. And the key components of that is going to be your RAID groups. You need to have 2 separate RAID groups, one for the host operating system and one for the StarWind HA device. And you'll see this later on in the tutorial how we create the HA device, and it resides solely within this dedicated RAID partition. Now, because StarWind treats everything as an image file, it is possible that you can configure an HA device that runs on the partition or even a RAID group that is shared by the host operating system, but it is not recommended, and we have not actually gone through and test that, but we have great performance from a dedicated RAID group for the StarWind HA device itself. You also need to have 2 network interface cards minimum. One is dedicated for your crossover connection for the sync and heartbeat connection, and then your other network interface card serves as your public interface so that objects outside of the clustered volume can connect to the virtual machines that are being shared within your cluster. And of course, you need a crossover cable to connect your private network connection together. We're going to take a look real quick at the server architecture for the servers I'll be using in the demonstration. Now for the minimum system requirements, I recommend that you go to starwindsoftware.com and look at the minimum system requirements for the StarWind Native SAN for Hyper-V software. In this instance, I have 2 quad-core Intel Xenon 2.4 GHz processors and 8 sticks of 4 GB DDR3 RAM. The most important thing that I want to reiterate is the fact that I have 2 dedicated RAID groups. I have a RAID 1 group that is set up for my host operating system so that I get a high availability within the host itself, so that if one of my hard drives for the host operating system crashes, the other one is still running and that my system is still up and going. Remember that the whole point of this is so that we can get high availability. The second RAID group I have is actually a RAID 5 group. Now I have more than 3 hard drives in my RAID 5 group, but for a fully functional RAID 5 group, you do need to have a minimum of 3 hard disk drives. And all of my hard disk drives in these servers are SATA 3s with 6 gigabits per second of throughput. Additionally, I have 3 network interface cards. Now I did say that you needed to have a minimum of 2. I actually have 2 network interface cards that are dedicated to the private side for synchronization within the StarWind software. And the reason for this is because when synchronization is happening, a full synchronization, if in the event of a catastrophic failure and one of my hosts goes down, when I make the repairs and bring that host back up online, I've only been able to get StarWind software to use a maximum of 54% of the total allocated bandwidth. And with a 1 terabit image that's being fully synchronized across, that could take a great deal of time. So to increase performance and speed, I've added a second network interface card for the crossover connection. Here we have a simple 2-node cluster network topology. Spanning across these 2 nodes is the StarWind cluster itself, but it's not a very good characteristic representation of how StarWind works because it's actually more like a RAID 1 array with one disk being on host 1 and the other disk being on host 2, and then those 2 disks being synchronized with each other. Also, we have the crossover network cable, which is used for the synchronization and heartbeat connection. And then we also have our public connection. Now, heartbeat is also achieved across the network connection, and the reason that happens is because if your switch goes down, we still want to make sure that the heartbeat is good, so that's checked over the crossover connection, or vice versa. If one of your network cards goes down, then you want the public network connection to be able to report that, hey, we're still up, we're just not going to be able to sync. The reason for this is because if it detects an outage, it will bring your virtual machines or applications up online on the other host. Now, if you have both hosts online on the same network at the same time, that can cause some conflicts. Additionally, if host 2 is accessible but host 1 is not, then when you reestablish that, there'll be conflicts, there'll be data gaps, and you're going to lose some of the data when they try and synchronize back up. The last thing that we need to cover before we get into the demonstration is the software that you need to have installed and ready to go before you can actually start to deploy your solution. The first thing you need is your operating system must be running Windows Server 2008 R2. Within your operating system on your host servers, you need to have the Hyper-V role enabled on both servers, and you also need to have the failover cluster and the multipath I/O or the MPIO featured enabled on both servers. You also need to have a copy of your StarWind Native SAN for Hyper-V software, and if you don't have it, there is a URL right there. You can go and download it. There is a free trial as well as a light version. The light version is limited on your data store size. 2 other critical pieces that you need to have is that your host operating systems must be members of an Active Directory managed domain. So you need to have your domain controller, and you also need to have DNS running on your network, and that is important for the actual Microsoft failover clustering services. Okay, so now we're going to go ahead and get started. Now, what I have here is I have the 2 servers already installed with Server 2008 R2 with the Hyper-V role enabled, as well as the failover cluster and the MPIO features enabled as well. On my second host, I've already installed the StarWind software, but on the first host, I'm going to go ahead and I'm going to walk you through the installation of the StarWind Native SAN for Hyper-V software to show you how easy it is to actually get done. So locate your installation file, you double click on it, you click next when the first screen appears, accept the license agreement, click next. There is some information in here that you may want to read through in regards to the capabilities with the StarWind iSCSI SAN and the StarWind Native SAN for Hyper-V. Select the default location. If you choose a different installation location for your StarWind software, you make sure that you document that someplace for later reference. That way, if you're having any problems, you need to uninstall or reinstall or whatever the case may be, you know where your software is located. Hit next. For this instance, we're going to select the full installation. We want the HA processor, the Starport driver, as well as the management console on the server. Hit next, select the rest of the defaults. If you want to create the desktop icon, go ahead and leave that checkbox enabled. Hit next and then tell it to install. Okay, the installation is finished. Go ahead and launch the StarWind Management Console, and now we're going to go ahead and get into creating our first HA device. Okay, now you'll notice I have both of my servers here listed, and they're, I'm going to go ahead and maximize this for you. The targets containers are both blank, as well as the devices. So both of these are fresh StarWind installs. So let's go ahead and we're going to click the Add Device icon, select the High Availability Device option, hit Next. Now you need to click the Add button because we got it, even though we have the second server here, we need to add it here within this list. So type in the IP address of your second server. I use the private network address. Now leave the target alias name as HA1. We're going to create an HA device from a virtual disk. So we click on the Options dialog box here. We double click the RAID partition or the partition formatted on the RAID group for the StarWind. And now at the end of this UNC here, you're going to add ha1.img. And that's going to be the name of the actual file it's going to create on the disk. Now, my license for StarWind is for 1 terabit, so I'm going to select 1000 gigabits, which is 24 gig less than a terabit. And I need that because I need 24 gigabit for my witness drive, or also known as a quorum drive. Go ahead and hit Next. You notice the target alias for the second device now is HA1 second node. I'm going to do the same thing here. I'm going to tell it to where the location of the file is going to be. Double click on my partition. I'm going to add to the end of this HA1 second node.img, and I'm going to tell it to create new. Notice it pre-populates the 1000 gigabit setting that I set on the previous screen. Both of the virtual disk size must match. I'll go ahead and click Next. Now, I have 2 private NIC cards for my synchronization and heartbeat. Now, my public NIC card is heartbeat only. But if you follow the default standard, then you're only going to have 1 private network interface card and 1 public network interface card. I use 2 because it improves the synchronization performance of the StarWind software between the 2 nodes. I'll go ahead and hit Next. Now you have several options here. What we want to leave is write back caching. That's actually going to be a little bit faster. It's going to improve the performance of your StarWind devices. And now for the cache size, the default rule is 1 gigabit per terabit of disk space. So I'm going to set it to 1024 meg. I'll go ahead and hit Next. Now because these are new disks, I do not need to clear the virtual disks because there's no files, there's no data within them. And synchronizing the virtual disks is irrelevant because they're brand new. We haven't created anything. I can go into these options in another time, but for now we're going to go ahead and just select Do Not Synchronize Virtual Disks so that way we can get through this tutorial a little bit quicker. And now it's going to go ahead and we'll hit Next, and it will go through and we'll create the HA device. And now it's going to go ahead and initialize it for us. Okay, so now we've created our first HA device, but we're not ready yet to actually do the bring it in and get it ready for the cluster. We need to add another HA device. This HA device is our quorum disk. Or also known as a witness disk. And essentially what that does is it's going to store any differential data in the event of a failure. So when the primary host comes back online, it will be able to sync everything up correctly. And we'll go ahead and call this quorum.img. We're going to tell it again, we're going to create a new one. This time I'm going to go ahead and set that to 24 gig. That takes up all 1 terabit of my license for this installation. And then we're going to do the same thing over here. And don't forget to add the img to the end of the file name. And we're going to select the same options for the synchronization and the heartbeat only. We're going to use write back caching. This time we're going to leave the cache size at 128 meg and do not synchronize the virtual disks. And then hit finish. Okay, so now we have both of our drives that we need to actually bring into the system. There we go. Now it showed up. Now we have both of our drives that we need so we can bring it into the system. So we're going to go ahead and we're going to launch the iSCSI initiator. I'm going to use the Quick Connect tool, type in the IP address, select the first drive and then the second drive on that IP address, and type in the IP address for the second server. Hit OK. Now we'll go over to Server Manager. We'll notice that we have 2 new disks that are now showing up. Disk 2 and Disk 3 are both showing as offline and down. So we're going to go ahead and we're going to bring these online. Then we're going to initialize the disk. And we're going to format it with the new simple volume. It's very important that you use NTFS file permissions. And I'm going to go ahead and name this one StarWind. And we're going to do the same thing to the quorum disk. Bring it online, initialize it, and then format it. And call this one quorum. Okay, now that the formatting is finished, before I can actually get into and create my cluster, I need to go over to my second server and make sure that I bring those drives online within it. Launch the iSCSI initiator. Okay, now you see that disks 2 and 3 are in here. So we'll go ahead, And we're going to bring this online. You notice I didn't have to initialize the disk or format it. It's already up and running for us. So that's all we need to do on your second host. We're going to go back over to the first host, and we're going to go ahead and get into creating the actual failover cluster. So we're going to run the validated configuration wizard. Hit the next, and we're just going to tell it the servers that we want it to actually include within this cluster, and make sure you tell it to run all tests. You hit next, it's going to go through the test for you. Now, if you don't run the test and you click the link that says create a cluster, it will ask you again, do you want to run the test? And I still highly recommend it, because that way it's going to let you know of any issues that you may or may not have. So you can go through the report, and we'll walk through it real quickly, just to make sure that everything is green. Okay, so our validate a configuration wizard is completed. We're going to go ahead and click on the view report button just to make sure that everything is okay with our system here. And you'll see that we only have one warning. That's for the system configuration. I have a feeling that is going to have to do with the drivers. Validate all drivers are assigned, and that's going to actually have to do with the SCSI adapter driver for the StarWind software, which is at this time not digitally signed. So I'm not going to actually worry about that one. So I'm going to go ahead and close that, click Finish. I'm going to go ahead and tell it to create a cluster. Same thing as before. We're going to type in the host names of the two servers I want included within this cluster. Hit Next. Now I'm going to give it a cluster name. And make sure that the IP address or a subnet that it's displaying is actually your public subnet. It has to be your public subnet for your cluster address. So make sure that that checkbox is checked. You can click inside here, go ahead and give it an IP address. Hit Next. And it's going to go ahead and go through. It's going to validate your settings. Double check your information here. Make sure that your cluster name is correct. The fully qualified domain names for both of your nodes is correct, and that the IP address that you want to use for your cluster is correct and not currently in use. One of the important things to reiterate here is that the username that you log in with must have permissions within your Active Directory domain to actually add computers to the domain. Because when we're creating a cluster, we are actually creating another object in the domain as a computer profile with the name that you actually give your cluster. So now we've created our cluster here. We got to do a couple more steps before we're actually ready to be a high availability. So we're going to go ahead and right click on the cluster and tell it to enable cluster shared volumes. Check the box that says I read the notice and go ahead and click OK. Now we've got our cluster shared here. We're going to tell it to add storage. We're going to select our disk. Let's go ahead and expand this. Make sure that it is in fact the 1000 gigabit disk that we created, which in fact it is. Go ahead and hit OK. Now it's created our it's created our cluster disk. We're going to go ahead and get this ready now to actually put in the virtual machine. Now I have a virtual machine that I've already created. I'm just going to go ahead and I'm going to copy this file. I'm going to put it into this new folder here that says cluster storage. Double click on that, double click on volume 1, and go ahead and paste that in there. Okay, a couple things I want to point out to you real quick. Yes, you do have to save your file to this folder. It is not an actual directory within your C drive. It's not going to take up space on your C drive. Maybe your host operating system partition only has a 100 gig file, and you're like, oh, I created this 1 terabit image. Where am I going to store it? This is actually a virtual directory. It redirects to your SCSI devices that are mapped in. This path must be the same on both servers. Otherwise, in the event of a failover, your virtual servers or virtual applications will not come back online because they won't be able to find the resources. So now we've copied the files over that we need. We're going to go ahead and we're going to create our first virtual server. So we're going to go ahead and tell it to, we're going to right click on services and applications. We're going to select virtual machines, new virtual machine. We're going to select the first host because that's where we copy the files to, and it is the current owner of the clustered shared volumes. When the wizard comes up, we're going to hit next. We're going to go ahead and name the machine. Now this is important. Store virtual machine in different configuration settings. This is correct. Cluster storage volume 1 VM. So we'll go ahead and hit next. Tell it how much memory you want it to have. On your network connections, select your actual network connection that you configured within Hyper-V. Now for virtual disk, if you don't already have a virtual machine, you can leave this as it is. Tell it to create a new virtual machine, and just make sure that the path that it's storing it to is in the cluster storage volume 1. Or like me, you already have a virtual hard disk, so you're going to actually go in and select the virtual hard disk. Hit next and finish. Okay, so now we've already created our virtual machine. It is a high available machine. We're going to go ahead and tell it to start. And you should notice now within Hyper-V, I actually have it listed here. Now that we've created this cluster, one of the other neat features that we have, because if you're anything like me, you're going to have multiple virtual machines running. We need to improve performance or whatever it may be. We'll go ahead and use the live migration feature and live migrate it over to one of the other nodes within the host. That process takes about 15 minutes or so, sometimes a little bit faster depending on your architecture. And the application stays live the entire time. The end users never see any downtime. And it's not an auto restart. It actually comes back up on the other Hyper-V host, fully running in the same state that it was in during the migration. One last thing that I want to really reiterate here is that this high availability solution is not an always up solution. With Hyper-V as well as VMware, what we have with the clusters is that we have what's called an auto restart feature, so that there is a catastrophic failure on one of the hosts that actually has a virtual machine running within it, it will auto restart on another host within the cluster. So if you're looking for a 100% uptime all the time, you need to take a look at something like Veritas. And of course, you're not going to be using StarWind. You're going to have yourself a tier 1 SAN from Hitachi or Storage Tech or one of these other big guys like EMC. As always, if you have any questions, feel free to leave a note down at the bottom. Shoot me an email, jason@sensiblecyber.com. I get to them when I have the chance. Again, thank you for watching. Don't forget to vote. And don't forget to take a look at our website, www.sensiblecyber.com. We have a lot of other great articles there, product reviews, and some other tips and tricks for administering your Microsoft Windows domain network.